Let's talk about the difference between reading mathematics and doing mathematics. Well, what does it mean to read mathematics? Well, reading mathematics is what most people do most of the time. Unless of course you're actually a trained mathematician, say with a PhD and you're several years of probably research behind you, then you probably find that most people who aren't in that position spend most of the time reading mathematics. Now, by reading mathematics, it's similar to reading a book. So someone else has written the book, they've already put all the words together for you, and you get to read it, and you can read it and enjoy yourself, and there's nothing wrong with that, and it's a great boon for you if you're well read. It helps you to understand, and it opens up all aspects of the world to you, and that's no different whenever you're doing mathematics. And I would have to say that I'm in a position where most of my time is spent reading mathematics, because that's what I enjoy doing. I enjoy working with mathematics and finding out exactly what other people have already learned. So there's nothing new in any of the videos that I put together. I never come up with the ideas. I just understood and worked them out and comprehended them, and I'm passing that information on to you. So I don't own that information. That information is freely available, and I never generated that information by myself. So in that sense, that's like me kind of recommending a good book to you and saying that I read this book and it was really good, and that's me passing on my recommendation. So that recommendation is actually in the form of the actual mathematics itself. Now, reading mathematics is different from actually doing mathematics. So by doing mathematics, that would be analogous to actually writing a book as opposed to simply reading a book. Now, writing a book is completely different from just reading it. Now, actually doing mathematics, I would suggest it's kind of like being in a dark room and you're fumbling about looking for a light switch. And after a while you manage to find a light switch, and when the light goes on, you find there's another door, and that other door leads through to another dark room, and again you fumble about in order to find the light switch. Now, by fumbling about, what I mean is you go from a place that you know to a place that you don't know. But in order to go from the place you know to the place you don't know, you have to follow the rules. Now, if you don't follow the rules, you will never ever find the light switch. You'll always be stuck in a dark room. And whenever you go to do to do mathematics, you'll find that you spend an awful lot of time in the dark, but whenever the light goes on, it's a real eureka moment. It's a real exciting time whenever your brain comprehends what is in the room, and whenever that light goes on, it gives you lots of different directions that you can go on. And doing that is probably, that's the most exciting part of mathematics. But as I say, me personally, I don't actually write a lot of mathematics. I spend most of my time trying to understand the mathematics that other people have already written, and I suggest that's what most other people who may call themselves mathematicians do, but personally I wouldn't call myself a mathematician. I just enjoy mathematics, and I enjoy reading mathematics, and now and again I head off into the hinterland, or I go off piste, or I actually try to do some mathematics. So the mathematics that I have done, as opposed to the mathematics I have read, is that new mathematics? Is that something that no one else has ever found out before? Well, the answer is no. There's nothing I've done in mathematics that hasn't already been found out or hasn't been done before. So let's go through an example of reading mathematics and doing mathematics. So let's look at this little problem that goes to the heart of the idea of reading mathematics and doing mathematics. So let's say I gave you this problem This problem is, tell me the area of this triangle. So that's it. You've got nothing else to go on. So in this instance here, we're actually doing mathematics. So you should be sitting there, if you don't know the answer to this, you should be sitting there basically in a dark room. You don't know the answer. You don't know where to go. There's no eureka. There's no light switch. You're just fumbling about. But what do we mean by fumbling about? Well, fumbling about is going to be different for every individual. So sit down for a few minutes and see if you can work out geometrically a little formula that will give you the area of this triangle. And the funny thing is that if you don't actually see the geometric problem, once I actually show you the answer, you'll just kick yourself for not noticing it. And you'll think, oh, that's so easy. But it's like everything in life, everything is easy once someone has shown you. And it was the same for me as well. This problem was easy after someone had shown me. So take a few minutes and try and work out the area of that triangle. So this is us now doing mathematics, and what we're going to do next goes to the very heart of this video. We're looking for a eureka moment that will tell us the area of this triangle. So what we could do is we could start drawing lines in this, internal lines, and see if we can work something out from them. Now how do I know that that's a way of progressing? Well, it's just because I've seen this type of problem before. And again, a bit of mathematical intuition will help you out here. But if I was to draw a line from this point here to this point here, so I'll just draw it in by hand. Then we could look at this and we know that's a little right angle, and so is that. But now, you might not see it yet, or you might actually have a eureka moment. So you can look and say, well, that's one triangle there, and there's another triangle. But you still might not see the route that I'm taking here. So if that's a triangle here, I can make a rectangle out of it simply by drawing the other triangle here. We could call that 1 dash if you want. But I could do the same with this triangle. I could draw another rectangle along here. Call this new triangle 2 dash. Now you might see the answer now, or you might still be sitting in the dark thinking, yeah, I still don't know where we're going with this. Well, if I said to you, what is the area of a rectangle? Well, we could call it this length here if we want. We can call it base, or we could call it a length, but we'll just call it base here, and we could call this the height. So therefore the area of this full rectangle, I'll just call it AR for area of rectangle, is going to be the base times the height. So now you should be able to look at this and think, now's my little eureka moment. If this area here is the same as that area there, and this area here is the same as that area here, then we know the full area is base times height. So this area 1 plus area 2 must take up half the area of the rectangle, and 1 dash and 2 dash must take up the other half of that rectangle. So that therefore means that the area of the triangle is going to be half of the area of the rectangle, which is base times height. So this is the equation that we're looking to derive. The area of the triangle is a half base times height. So what we've been doing for the last 5 minutes is mathematics. So if you didn't know the answer to this and you sat down for a few minutes and you were able to get the answer yourself, then really well done. That's you doing mathematics, that's you off-piste. You're in effect creating new mathematics. Of course, this mathematics is already known, but that doesn't matter. If you've created this new mathematics in your own head, then it's new to you and you've created it. So you should give yourself a pat on the back. Now if you weren't able to do this and create it, don't worry, you probably find that 95% of the people that you ask, or 99% of the people you ask, wouldn't be able to do it either, so don't worry about it. So that was us doing mathematics. What would be reading mathematics? Well, reading mathematics would be me coming along and saying to you, the area of a triangle is equal to a half base times the height. And I would say to you, here's a triangle, and the base is 2 and the height is 3, and I say, what is the area? So to find the area, you use this formula. You pick up the A and you say it's equal to a half the base, which is 2, times the height, which is 3, which equals 6 upon 2, which is 3, and you could just call it units squared. So this is us reading mathematics. Now you might look at that and think, well, what's the point reading mathematics? That's all really quite simple, but it's not always easy to work out mathematics. The mathematics that someone else has already done, it gets very complicated and it gets very interesting, and reading mathematics is fascinating. But actually doing mathematics is, I suggest, harder, but you get much more reward from it. Meaning you actually get a really good comprehension of why it is that the area of a triangle is a half base times height, as opposed to me just coming along and telling you it is, and then showing you, and then you just sticking the numbers in and getting an answer. So that little problem goes to the heart of the idea of actually reading mathematics and actually doing mathematics. So that's a simple example that goes to the heart of the idea of reading mathematics, of doing a problem and actually doing mathematics. Now it's a very simple example, but we could continue and find more and more examples like this, and they're not always geometric examples as well. They might be purely algebraic examples. In fact, if you're doing mathematics, the possibility or probability is that the mathematics you'll be doing will be algebraic in nature and not necessarily geometric. Now I've left a document in the resources section. Now I never wrote this document, I just got it online. It's called Lockhart's Lament. It's quite a famous document, and it goes to the heart of the problems with teaching and learning mathematics. Now I don't necessarily agree with everything that's written in it, but I think it's well worthwhile having a read of it, because you might understand that possibly if you've done some mathematics before and you got bogged down and you got fed up, or you didn't see the point, then if you were to read this document, I think you would understand why it is that you may well have felt like that in the past about mathematics. So I suggest you go ahead and have a little read of that. It's a bit of a not really mathematics in the sense of the mathematics we've been doing the rest of the course, but I think it's very, very worthwhile just to open your mind up about what mathematics is and how some mathematicians think, and what some mathematicians actually think about how mathematics is taught. So thank you for listening to this video. I'll get you in the next video. Goodbye.